I'm Dylan Pratt. I'm the Director of Engineering here at InterLink Engineering. Most of you already know me, but in case you don't, today I'm planning on doing a kind of quick, think of it more like a quick overview of TolAnalyst and DimXpert. We're not going to go super deep into the topic, but I want to show you what exists and kind of give you some context. So if you want to know more, you know it's there. You kind of have a pretty good idea of what you could do with it, and maybe you just need to dig in a little further if it seems like a good fit for what you're doing, is my goal. And yeah, we'll kind of just dive right in. And then, well, I should say afterwards, Kenny with Hawkridge is going to do an awesome presentation. And then there'll be some gifts and stuff as always to get your hands on. So let's dive in. So as far as TolAnalyst and DimXpert goes, we're going to be talking about, DimXpert and kind of auto dimensioning basically your parts. So using that feature to really very quickly get all the critical dimensions you want onto your part in 3D, not in 2D. And then using it though to then create your drawings very quickly versus doing a lot of manual clicking, smart dimensioning, etc. And then also the benefits of using DimXpert that way, one for drawings, and then also for doing tolerance analysis, because if you've already pre-done that work for all your drawings and stuff anyway, all that data is there. You can also use a cool feature called TolAnalyst to give you a breakdown of your fits and everything. So that should be pretty useful as well. And then we're just going to jump right into a demo.
Plus it ties into MBD.
Yes, and it ties into MBD. Yeah, I'm like circling all around MBD, but I'm like not going into MBD. But yeah, it all comes down to MBD, SolidWorks MBD being model-based definition. So using, to correct me if this is a poor summary, but basically using 3D modeling or 3D dimensioning rather than 2D drawings anymore is a big part of that.
It's a replacement for 2D drawings.
Yeah, that's a better way of putting it. Yeah, replacement
for. You model 3D, you CNC off of your 3D.
Yeah.
You can inspect in 3D. And
yeah.
That's the whole idea that drawings just become paperwork at that point.
Yeah. And so similar thing, yeah, if you're using tolerance analysis, the DimXpert and everything at that point, you also then could just jump into MBD and really get rid of drawings altogether. I'm going to be showing more how to then, sorry, looking at the projector, there's a delay, it's throwing me off. I'm going to be using it more to show you how you could make drawings faster, but absolutely you could just negate drawings altogether. And I'm sure soon that will become more and more common. Let's take a look at a really simple part here. This is this is a part we did for clients, something used in a mold. It's pretty simple, right? Obviously not very complicated, not a lot of features to mention, but it's still going to take a few minutes to drop that on a drawing and whatnot. There also might be a lot of things this is mating to that have critical tolerances, so that would maybe apply. But in this case, so your DimXpert tab, if you don't use DimXpert, it's this tab here that you never go to. Next to your appearances and your configurations. It is there. You've just been ignoring it. Yeah, does everyone just ignore that tab? Perfect, I'll show you why you shouldn't. So in this case, I'm going to show you how quickly we can auto dimension this. There's a few different ways. I'm going to just choose my datas here. I think this is our most critical face there. And everything else is just kind of, I want the front and side. I'm selecting my datums. In this case, I could tell it to give me like what it thinks, give me a best estimate on the GD&T, but I actually am just going to keep it pretty simple. Go plus and minus tolerances. I could also tell it I only want to dimension certain features. However, in this case, I just want it to dimension the whole thing for me. So let's do that. Click those things, also unhide my annotations, and that's all the dimensions. And in reality, that is most of the dimensions. There's a couple of things there I missed, but pretty much immediately it got almost everything on there. So now your 3D model has your built-in dimensions and tolerances based off those datums you just selected. There's a couple things you may look at and go, I'm trying to think of a good one right now, but actually I don't care for that. I want that dimension to go off something else. You could just delete that, add a different one. In this case, I'm going to add the exact same dimension, hypothetically.
And the colors that were displayed there, folks, shows you whether the feature is fully defined or not.
Yeah, good call. Yep. Yeah. Yeah, I found that feature, it's really nice, but it also links it like it just disappears also. So it's a little on and off, or like you can
Toggle it on.
is that what it is? Okay. Yeah. I haven't played with the coloring. It's nice as like an initial what it got, but yeah, I often just have it go away, but I don't worry about it too much. Anyway, once I have those dimensions, couple things to consider there. Maybe it's going to default to some tolerances based on my settings. Those settings are here in your document properties. There's lots of options here that you're going to want to consider. You can do just a block tolerance, how many decimal places, your general values you're looking for. You can also do different types of dimensions based on, so like this is the typical tolerance I would want for a diameter or for a width. This is, yeah, for locations. There's am I trying to, yeah, display options is a good one. So like, this is how I like to display, so yeah, those on the drawing anyway, it's basically, yes, you can consider those annotations and show those as well. What I did isn't the dimensions that I modeled to. Those are just dimensions based on the datums. Now, if you modeled to your datums, then in theory, those are the dimensions that you modeled to, and they are already there. And you could just unhide, you could basically not unhide, you could basically show those dimensions instead of creating new dimensions, but you don't get some of the other benefits of DimXpert. So still quickly going through and adding them into DimXpert does give you additional benefits. Yeah, and I'll show you how to incorporate that onto the drawing in here in a second. But yeah, maybe I want to, maybe I like my slots dimension differently. So this is where you can select that too, so that DimXpert does all that for you. If my default tolerance, I wanted to be tighter, for example, it'd be good if my num lock was on. If I wanted that to be 7 thou instead of 10, maybe that's my default tolerance. Now, if I select, well, that one's already defaulting to 5 because of the other setting, but you get the gist. You can adjust those, and that can be all driven from your template, whatever like part template you have. Yeah. So anyway, we got your DimXpert there. So I'm just gonna make drawing, show you how that looks. Throw a view on. And I've told it, I'll show you again where that button is, but in just a second. But I told it to use the imported DimXpert views or DimXpert. That's interesting. Why did those all disappear? Oh, maybe that was I. My template didn't by default show annotations, so just look out for that. Show DimXpert annotations, even though I also imported DimXpert annotations. So when I drag the view in, I made sure to check import DimXpert annotations, and then also I showed them here. And this is where you could also have, grabbed, where is it? Oh, model items. I just missed it before. So model items is where you could do this very similarly, but with the dimensions stuff that are in your model. So in your actual features, that's what model items will do. You don't get some of the tolerance stack stuff that I'll go over in a minute with that though. But yeah, as you can see, basically within a few seconds, I've got this model, or I'm sorry, this drawing pretty much laid out because I already had the DimXpert annotations on there. Now maybe I want to like drag things around a little bit, clean up the view. Maybe this should really be 3 decimal places. Things like that can be adjusted. And I can also override, or no, that's for overriding. Oh, I think I need to adjust because those are DimXpert. I need to adjust that dimension and the significant figures within DimXpert. So I would have to go back here and tell it that should be 3 significant figures. But again, it's really nice because also now when you open up the model, even if somebody opens the model and not the drawing, they can see your critical dimensions and things called out. You could also drop notes here. If you wanted like to make sure certain call outs are also in the model for viewing, things like that. Personally, I like everything being controlled off the model. I want my drawing to be completely slave to the model. So I really like using this feature for that. It's also it doesn't break as much. You know, how many times do we change our model a little bit? We go back to the drawing and the drawing's totally broken or various dimensions are broken. Your DimXpert doesn't break as often or as easily, and you can always just recreate it really easily. So that is creating a drawing and using DimXpert for that. Before I jump into the next part of DimXpert / TolAnalyst, do we have any other questions?
Just a quick comment.
Yeah.
When he was showing tools options in document properties,
Oh yeah, I can go back to that. Oops.
all that stuff, you should really set that up for your main template. Because what he's about ready to show with TolAnalyst is your tolerance analyst guy will be really upset if this is set up correctly.
That's true. It does make things a lot easier if you've pre-decided that these are your typical tolerances on a lot of things. Yeah. No, absolutely. Yeah. Very, very good point. Yeah. Yeah. You may choose to have a part template. Maybe you have 2 or 3 different templates like, oh, this is going to tight tolerance part. This is a medium tolerance part or something, just to get you in the right ballpark. You know, you're going to do a sheet metal part versus a machine tight tolerance part. Maybe you have a couple of templates for that so that you have your predetermined tolerance blocks here more configured that way. Yeah, because nobody wants to hold their sheet metal to like plus or minus half a thou or something. Yeah, or let me rephrase that. Your sheet metal manufacturer does not want to hold your stupid tolerance. Yeah. Yeah. Oh yes. Yeah. Let me. Yeah. So in this case, because I didn't call out using GD&T, it didn't actually call out datums per se. What I did is I selected what I wanted it to dimension from. So in this case, when I selected my datum right here, I selected this surface. Now, it didn't establish a datum in the sense of calling out datum A. It just dimensioned everything from that surface, knowing that I wanted it from that. But it absolutely could, and it's a good point. So I can call out using geometric tolerance type versus plus and minus. And when I do that, I'm just going to kind of quickly click these. I should get a datum established here. Yep. So we've got datum C, datum B, and datum A now. And it did again, based on the template settings and its, interpretation, it did a guess on what I would want. And in reality, do I care about that being perpendicular -4 or so in relation to datum A? No, probably not, but not a bad guess, and I could make those changes pretty easily. So I could just delete that tolerance. Maybe worth noting also, even if I didn't do, because I wasn't going to show this later, even if I didn't do GD&T, if I just did the plus and minus again, what I can do is still go back in and tell this, no, I want an official real datum call out here. Just going to change that back to except with the caps. So handle that way. And so I've also added that datum officially, not just even though I'm not actually GD&T calling out anything at the moment, but maybe I want to mostly have this basic kind of tolerancing, and then I just want to have a single GD&T call out on this face. I can just add that separately and build out my, whatever. I'm gonna hold that flat to 10,000, something like that. And that'll build that all out. But you can see how easy this is. I mean, I've dimensioned this part, what, 6 times we've been talking? Like, I mean, versus me trying to tell out my drawing manually. Or a lot of times we might be doing a model and we don't always know when we start. Maybe it's a conceptual kind of building it from scratch, kind of, basically at the time, maybe there's a reason we didn't know or we decided to switch datum. So it might be modeled in such a way that didn't control. So if you wanted to use model items, the way it was modeled didn't really optimize those features for that. But with this is all post modeling it, you can retroactively dimension it as the way you would want it going forward, even though it may not have been modeled that way.
It'll work on imported models too.
Great point.
So I'm just curious, this each model, right, would actually say you're in English units right now? You're in inches right now?
Yeah, I'm in inches. Yep.
Curious. Oh, like, where exactly know that? I mean, I can tell they'll leave 0 in front of the decimal point, but besides that, I wouldn't.
Yeah, good eye. The only other place by default you would assume is this here, just as IPS in the bottom right. So you would know from that. But yeah, you would definitely be using a little interpretation too. Yeah, you're right. Well, actually, no, I apologize. There is also an inch call out there. I missed before. Yeah. I didn't actually see that before. Same thing goes with like a lot of the same things we do with smart dimensions you can do. So in this case, I'll probably show this later also, if it may not need to, but anyway, I can decide I want to dimension this as a diameter instead of a radius. Doesn't really make sense for this part, but there are times where things like that come in. So you can change that and make sure it's dimensioned the way you want really easily. I think the main thing it didn't get was the angle here, basically. So like an angle and maybe one distance, it didn't import very well. So I would just manually do that. And I'll show you doing some more manual dimensioning here in just a second. So I'm gonna do a quick manual dimension and tolerance stack up on this. So this is a camera housing, like a heavy duty cast and machined camera housing for like wash down environments that we help design. Tolerances are pretty tight because everything's like waterproof and O-rings and all kinds of stuff. So there's more features on here, but I'm going to kind of simplify things and we'll just look at fit between these two parts. I want to basically make sure that this slip fit is going to be a slip fit. So I want to make sure we tolerance that correctly. Now in reality, I've already done all that and we did tolerance it properly and it did get machined, but let's pretend for a second I didn't do that. And I wanted to check if we've toleranced it properly now. What I'm going to do is just throw on a couple dimensions. I'm not even going to worry, like, let's say I'm not doing a drawing for this. I'm just throwing in a couple dimensions because I want to do this analysis. I'm going to just throw a diameter. So I'm going to click my size dimension. I'm going to throw a diameter on that ring there. That's where my O-ring fit is, my slip fit. And I'm going to do a location tolerance for how deep that pocket is. And, we could dimension a handful of other things, but realistically for the kind of very basic analysis we're going to do, that will be sufficient. I'm going to go over to this part, same thing. To do the tolerance analysis, you do need the things you're looking at to be dimensioned this way. If you don't have them dimensioned, it won't work. It'll give you a message basically saying you haven't laid in your dimensions, which I'll show you that error in a second. So I'm going to throw my diameter on there as well. Same thing, I'm going to measure this height just to cover my basis. You can see it's throwing in the dimensions here. It's also automatically throwing on the tolerances I wanted at 5 plus or minus 5 thou. Just to something I meant to mention earlier and I forgot to, so I'm gonna mention it now. If for some reason I don't like this is probably like the right view. So when I put this dimension in, it automatically selected the front view as the view for that. Maybe there's a reason on this part, it doesn't really matter because it's circular, but maybe there's a reason I want to actually see that on the right view. If I select the dimension and hit tilde, so, just above tab, the tilde key, I can tell it which plane I actually want that dimension. I can move it to the right dimension.
And that's an embedding.
Okay, perfect.
Yep.
So that allows me to move around things so that on that drawing, right, if I put on the right view, let's say the front view is way too congested, and I want more dimensions on the right view, I can go into the part, say, hey, move these 4 dimensions to the right view because it's a good dimension in either view. Then you can kind of clean things up and have it look that way for you. Anyway, yeah, so I got those dimensions in here. Go to my assembly. And now essentially I'm going to go back to the little tab that none of you go to. And this time, and actually I'll show you real quick too. You do need professional or premium to have the TolAnalyst, just for reference. So it's just an add-on, you just need to turn it on. And this will let you click this checkbox or this icon. You select the TolAnalyst study. And then the first thing you need to do is just select the faces, basically you're selecting the faces that you're checking a dimension to so that you are establishing what your nominal is, right? So for doing a tolerance analysis, what is your nominal expected value, in a perfect world? So in this case, I'm going to select both my diameters. I just need to hide and unhide parts so I can show them. Select my 2 diameters. I'm just doing this in a section view. You don't have to. Just helping me. Now it's going to default to dimensioning centers. These are concentric though, so dimension will be 0. I don't actually care about the centers. What I care about is the gap. So I'm going to change that to max. And you'll see over here, we have a 3 thou gap between those two. If some of you are good at math, you might have already figured out what I'm going to find out here soon. So fairly easy initial analysis. And then basically I'm going to select my parts. So if this were a more complicated assembly, I'd have more parts to select. In this case, they're really just 2 parts. The order doesn't really matter. If you have more than 2 parts, basically you want to select them in the order that the assembly matters to you. It's one of these menus where you have to select left and right to go through the sequence. Don't hit the green check mark. I mean, you can always go back to it if you did hit it, but it's one of those kind of hidden menus you got to keep clicking through. Similarly, this is a pretty simple assembly, so you need to select the mates that matter the most and in the order that they matter the most, basically. In this case, similarly, there's basically 2 mates that really matter to me, a coincident and a concentric. Doesn't really matter. It's not going to hugely affect the analysis. So I'm just going to click 1 and 2. Then I'm going to click through again. And basically it's doing the analysis. So it's doing a root squared, root sum squared. Sorry, that's what the SS is. Analysis here. Obviously very quickly in this case is very basic, easy one to do. But I already did the analysis. My nominal dimension is 3 thou, which we knew. And then I've got a worst case values essentially, and the RSS min and max. So essentially nominally it should be 3 thou. I've got a negative 2 thou min, meaning worst case, and a max of 8 thou. So essentially what that means is I've got a problem. If I'm expecting something to be a slip and I've got a negative 2 thou clearance, well, that's going to be quite a tight slip fit. So also called a press fit. And the root sum squared, if you're not familiar with it, essentially is an analysis to kind of tell you, in this case, I believe there's one oh shoot, I just forgot the term. Well, basically it's telling you on average, 60% of the time your parts are going to be within these dimensions. So even not worst case, most of the time my part could be within a bad tolerance there at -1 thou. So that's where we should probably go back and fix that. So let's say I want to select this diameter. I'm going to change this to 3 thou so we can, or 3 significant figures, so we can actually see it. And then let's just say I'm going to change that to 1 thou. That's going to be ±1 thou on those diameters. That's a critical dimension for me. Same with this guy, we're going to do ±1 thou. And then I'm going to go back to my assembly. I'm going to hit rebuild. Have it redo I'm going to go into edit feature. So that basically reruns the analysis. And as you can see here, now our nominal is 3 thou, but our worst case is 2 thou and our best case is 4 thou. So now we're within tolerance and we're getting what we're expecting. And you can also export results. So say you got like a presentation or something, or you want to break out the math. Okay. Oh, where did I send that? Wasn't paying attention. Let me just save it into my downloads. There we go. Okay. So here it's breaking out various things for you in a more of a friendly environment, Excel, where you can, click through, see what it's doing, see major contributors to the tolerance also, which you can see here, which is pretty handy. You can see, again, this is a very basic analysis. So there's only 2 parts, but you can see what's affecting that the most. So let's say I had 3 or 4 parts. One of the tolerances, the way things were coming together, let's say we had like a ±10 or 20 on some feature for some reason. And that feature alone was what was 90% affecting the tolerance, making it negative. Well, now I know what tolerance I need to fix primarily, right? Rather than spending much time trying to make that ±1 thou, it might be something else that just needs to be changed from ±20 to ±1. I'm sorry, ±5. So yeah, gives you all the major contributors here, which is really convenient. And then, like I said, same in the report, you can kind of dig through it and see what it's doing and get all your values. I think I'm probably running a little long, so I will try and wrap up, but any questions before I do?
My one thing is the parallel and the axis, right? Especially in complicated assembly. It's very hard to see where the maximum influence is.
There's orientation adjustments. He was using the root sum of squares, but there's a orientation tolerance as well. That will take into account parallels and then perpendicularities.
But yeah, you're right.
So when they give you a graphic, this one showing you how much you have in parallel, right?
Mm-hmm.
In a complicated assembly, they would give you this obscure yellow paint. It's very hard to see. Has that feature been upgraded in the new version, or is that still in fashion? Joe, you know what I'm going at. So
Yeah. Have you called into support? What do they tell you?
That's the way it is. So
I mean, did they issue you an SPR?
no. So
If there's no SPR, they're not fixing it. Support is supposed to report stuff if it's erroneous.
I don't mean to plug it.
No, that's
There are
fine.
better tools called 3D CS.
Okay.
Mesh around all.
Oh, cool.
So if you guys do all of this work with the DimXpert,
Yeah.
actually make all the stuff in.
Oh, cool.
And it's very expensive module to add in, but rather than seeing an Excel spreadsheet, you can actually see the parts in the movie.
Oh, nice. Yeah, that is really convenient. Yeah.
So it's a little more powerful because it uses more of an FBA.
Yeah.
To it, but that was one thing I think you remember working with me on that. So
It's been a while.
You said 3D CS?
Yeah, 3D CS.
Okay.
Yep. Bringing in dimensions, because I mean, we're dimensioning in the model,
Mhm.
then you gotta go back and dock the dimensions on the drawing. And so the model-based dimensioning is a great approach to solving.
Yeah,
both, right?
yeah, definitely.
So I'm really kind of excited about seeing the new features of 2025, being able to support that, because I don't have to do double work. That's why I kind of.
Yeah.
That's why you never use that button.
Yeah, fair enough. Yeah. Yeah, yeah. Yeah, we're certainly all trying to do less.
I
Yeah.
don't use MBD enough to know that whether anything's been fixed in 25 or not.
Yeah, so I heard rumors that they can import the dimensions, so I'm really excited to just get that installed. And going. So, but yeah, other than that, it's a really, actually very powerful tool.
Okay,
People use it quite as much as they should, so.
definitely.
Sure, I appreciate your effort on the presentation.
Yeah, yeah, yeah. Yeah, just if nothing else informative, I know we've been underutilizing it. So my plan is to utilize it more as well. And yeah,
That doesn't
definitely.
fit, because you didn't do this.
Yeah, yeah, exactly. Yeah, definitely. Yeah, and it a lot of times like, we might just do something in our head for one or two parts. The stack isn't anything great. We know like, okay, well that was plus or minus 5. I know this is plus or minus 5. I know I've only got 3 thou. I'm smart enough to know that ain't gonna work, But you add 3 or 4 more parts, a few interactions that you're not accounting for, and it's very handy to do something like that.
Precedence, your mates is really important. too.
Yeah,
So,
yeah, absolutely.
very-
Yeah, yeah. Yeah, good point. Perfect. Well, I think we'll just take a second and switch over to Kenny, and then we'll go on from there.